Now, from the uncertainties of fiction to the uncertainties of science.
If you watch something closely enough, you realize you have no possible way of telling where it's going or how fast it's getting there. Did you know that? If you pay attention to where it's going or how fast it's moving, you stop watching it properly. That's the truth. That's actually scientifically been proven as the truth.
The play takes its name from the physicist Werner Heisenberg, whose uncertainty principle, the idea that you can precisely measure a subatomic particle's velocity or its position, but not both at once, becomes an analogy or metaphor for the irreconcilabilities of the two characters in the play. You'll remember that I promised you more uncertainty, and I wouldn't like to disappoint. To discuss the uncertainty in the play, as well as the uncertainty that stalks us all, I'm joined by the science writer Marcus Chown, literary historian Rachel Hewitt, whose latest book, A Revolution of Feeling, examines the tumultuous 1790s, and the novelist Lionel Shriver, whose most recent novel, The Mandibles, prospects for gold in that most uncertain of places, the future. Marcus, can you get us standing on steady ground to start with at least? How do scientists understand the Heisenberg principle?
Well, I'll try. The ultimate building blocks of matter are not like anything in the everyday world. They have a strange kind of wave-like character, like waves on a pond. And the Heisenberg uncertainty principle is actually quite a trivial consequence of that. If you imagine a little hump of water on a pond, you can't locate where it is because it's kind of fundamentally spread out. Waves are fundamentally spread out. If you were to try and squeeze it into a smaller space, it would become more choppy. It would become more humped, which corresponds to having more energy. So there is a trade-off between knowing exactly where a fundamental particle like an atom or a constituent of an atom is and its energy or momentum. You can't know both. And interestingly, Heisenberg himself misinterpreted his own principle.
Oh, so it couldn't get more confusing and uncertain.
Because he thought it was about measurement. And we see each other because photons, particles of light, bounce off us and come back into our eye. And he imagined that when we're looking at the very small building blocks of matter, those photons would have a big effect because the things are small. And so trying to locate an object would be like trying to picture a chair by throwing cannonballs at it. You throw the cannonballs at it and you actually disrupt or destroy the chair in the process. But it turns out that he was wrong, and it's absolutely nothing to do with measurement. The uncertainty, the fuzziness of the microstructure of the world is utterly fundamental. Something completely new under the sun. It's nothing that appears in the everyday world, this randomness.
You're trying your best, Marcus, but I'm just throwing cannonballs into the pond at the moment. Is the uncertainty our fault? Is it the means by which we try to measure something alters our findings, or is it that there is an inherent uncertainty to the atom itself?
It's inherent. I mean, the fundamental world is like this Alice in Wonderland world where things happen for no reason, where things can be in two places at once, and as I say, the randomness, the unpredictability is fundamental. There's nothing really unpredictable in our world. We may think that when we throw a dice, it comes up at 5 or 6. That's random. But if we actually knew, the air currents, the friction between the dice and the table, all these kind of things, in principle, we could actually always predict the outcome. But the processes that happen among atoms are fundamentally unpredictable. They're not a function of us not having a good enough measuring instrument or not having enough information. It's something entirely new under the sun.
Rachel and Lionel, let me get you in here because you were at the theatre last night and there were no cannonballs being thrown into ponds. But what was your sense of the uncertainty principle from the play last night?
Well, I thought we were being asked to juxtapose the idea of living in the moment aside an idea that we're trying to understand where we're getting to and how fast we're getting there. And in the extract we heard, she's making the point that if we're focusing on the future, we're focusing on our goals, we're focusing on how to get there, then we're not paying attention to what's happening in the here and now. And I don't think that it's any coincidence that in the play we are told that this is a period of huge kind of global uncertainty, of anxiety. The very aptly named Alex Priest is worrying about climate change. The more aptly named Georgie Burns, Geo Burns, is worrying about some sort of catastrophic space event that's going to destroy the world. And I think it's really notable that, you know, throughout history, in these periods of huge uncertainty, of anxiety about political convulsions, about geopolitical convulsions, about sort of geological worries, that these sorts of ideas about how to respond to uncertainty come out of them. And in the play, we're being told that, you know, that we give up the search for certainty, that we embrace uncertainty and we live in the present moment.